Hello students, I hope you are all doing well. I welcome all of you for today's class. Today we are going to learn very interesting concepts about numbers. In fact, in our previous classes we learned many things about numbers like different types of numbers such as natural numbers, whole numbers, integers and rational numbers. We have also studied different properties of numbers and explored finding the factors, multiples and the relationships among them. So, in this class, let us try to explore more about numbers by playing some games with them. Students, before we begin to play with them, let us try to understand a very interesting fact about numbers. Look at the number 73. 73 is equal to 70 plus 3, that is equal to 10 times 7 plus 3. Similarly, 89 can be written as 89 is equal to 80 plus 9, that is equal to 10 times 8 plus 9. Students, similarly, given any two-digit number AB made of digits A and B can be written as AB is equal to 10 times A plus B, that is equal to 10A plus B. Students, make a note that here AB doesn't mean A times B. AB is not equal to A times B. It is a two-digit number where B is in units place and A is in tens place. Hence, AB is equal to 10 times A plus B. Similarly, BA can be written as BA is equal to 10 times B plus A, that is equal to 10B plus A. Students, now let us try to understand the same thing for three-digit number. Look at a number 347 and it can be written as 347 is equal to 300 plus 40 plus 7. So, that is equal to 300 can be written as 100 times 3 plus 40 can be written as 10 times 4 plus 7 can be written as 1 times 7. Similarly, the number 129 can be written as 129 is equal to 100 plus 20 plus 9, that is equal to 100 can be written as 100 times 1 plus 20 can be written as 10 times 2 plus 9 can be written as 1 times 9. In general, a three-digit number ABC made of the digits A, B and C can be written as ABC is equal to 100 times A plus 10 times B plus 1 times C. Students, similarly, can you try to write for CAB and BCA? You observe that CAB is equal to 100 times C plus 10 times A plus 1 times B and BCA is equal to 100 times B plus 10 times C plus 1 times A. Students, try to answer the following question. Write 100 times 8 plus 10 times 0 plus 1 times 6 in usual form. Yes, we observe that 100 times 8 plus 10 times 0 plus 1 times 6, that is equal to 100 times 8 is 800 plus 10 times 0 is 0 plus 1 times 6 is 6. So, the sum is 806. Students, here we have Meenakshi and Sundaram who are ready to play with numbers. Let us also join with them. Now, in the first game, Meenakshi will start the game and Sundaram will follow her instructions. You can also play this game by following Meenakshi's instructions. So, here we begin the game.
Hi, this is Meenakshi.
Hello, this is Sundaram.
Choose two-digit number but don't tell me what it is.
All right.
Reverse the digits to get a new number.
Okay.
Add this to the number you started with.
All right.
Now, divide the answer by 11.
Okay.
There won't be any remainder.
Yes, you are right. But how did you know?
Students, I am sure that even in your case you have ended with no reminder, isn't it? Well, let's have an overall view of their conversation. Students, how is this possible that for any of the 2-digit number we had chosen, we ended with no reminder? Let's try to see whether if we can explain Meenakshi's trick behind it. Students, firstly Meenakshi asked to choose a 2-digit number. Suppose Sundaram chooses the number AB, which is the short form for the 2-digit number 10 times A plus B. Later, Meenakshi asked to reverse the digits to get a new number. On reversing the digits, he gets the number BA, that is equal to 10 times B plus A. Later, Meenakshi said to add this number to the number you started with. So, when he adds the two numbers, he get 10A plus B plus 10B plus A, that is equal to 11A plus 11B. That can be written as 11 times A plus B. Students, make a note that the above sum is always a multiple of 11 as Meenakshi claimed, and hence if we divide by the 11, we get the quotient A plus B, which is nothing but the sum of the digits A and B. The game between Meenakshi and Sundaram did not end. So, let's again join with them. Again, you can also play with her by following her instructions.
Choose 2-digit number but don't tell me what it is.
All right.
Reverse the digits of the number to get a new number.
Okay.
Subtract the smaller number from the larger one.
All right. I have done the subtraction. What's next?
Now, divide the answer by 9.
Okay.
I claim there will be no remainder.
Yes, you are right.
Students, I think I know that you are sure about it, isn't it? Let's see whether if we can explain it. Suppose we choose the 2-digit number AB, which is equal to 10 times A plus B. After reversing the digits, we get the number BA, that is equal to 10 times B plus A. Since we need to subtract the smaller number from the larger number, here we have 3 different cases based on whether A is greater than B, whether A is less than B, or A is equal to B. So, let us look at the case number 1. If the tens digit is larger than the ones digit, that is A greater than B, we get 10A plus B minus 10B plus A, that is equal to 10A plus B minus 10B minus A, that is equal to 9A minus 9B. By taking 9 common, that can be written as 9 times A minus B. Let us see the case number 2. If the ones digit is larger than the tens digit, that is B greater than A, we get 10B plus A minus 10A plus B, that is equal to 10B plus A minus 10A minus B, that is equal to 9B minus 9A, that is equal to, by taking 9 as common, we get 9 times B minus A. And now, let us see the final case when A is equal to B. If both are equal, that is A is equal to B, we get 0. Students, observe that in all these 3 cases, the number is always divisible by 9, and hence we get the remainder 0. We can also find that the quotient is A minus B or B minus A based on whether A is greater than B or A is less than B. If we look at the Sundaram's case, Sundaram had chosen the number 96 where 9 is greater than 6, and hence the quotient is 9 minus 6, that is equal to 3. Now, it is Sundaram's turns to play the game. So, you also follow his instructions with Meenakshi and take part in the game.
Think of a 3-digit number, but don't tell me what it is.
All right.
Reverse the digits to get a new number.
Okay.
Subtract the smaller number from the larger one.
Alright. I have done the subtraction. What's next?
Divide your answer by 99.
Okay.
There won't be any reminder.
Yes, you are right.
Students, let us see how this trick will work. Let the 3-digit number chosen by Meenakshi be ABC. That can be written as 100 times A plus 10 times B plus C. After reversing the order of the digits, she gets the number CBA. That is equal to 100 times C plus 10 times B plus A. Since she need to subtract the smaller number from the larger number, it depends on the value of A and C. So, based on this, we have the following 3 cases. In the case 1, if A is greater than C, then the difference between the numbers is ABC minus CBA. That is equal to 100 times A plus 10 times B plus C minus 100 times C plus 10 times B plus A. That is equal to 100 times A plus 10 times B plus C minus 100 times C minus 10 times B minus A. That is equal to 99 times A minus 99 times C. By taking 99 as common, we get 99 times A minus C. Let's see the case number 2. If C is greater than A, then the difference between the numbers is CBA minus ABC. That is equal to 100C plus 10B plus A minus 100A plus 10B plus C. That is equal to 100C plus 10B plus A minus 100A minus 10B minus C. That is nothing but 99C minus 99A. That is nothing but 99 times C minus A. Students, finally, let's see the case number 3 when A is equal to C. If A is equal to C, then the difference is 0. Students, observe that in all these 3 cases, the number is divisible by 99 and hence we get the remainder 0. In fact, we can also see that the quotient is A minus C or C minus A based on whether A is greater than C or A is less than C. In the Meenakshi's case, the number chosen was 901 where 9 is greater than 1 and hence the quotient is 9 minus 1 that is equal to 8. Students, let's play the final game. Now again it's Meenakshi's turn. So, you can also follow her instructions and take part in the game. So, let's begin game number 3.
Think of a 3-digit number.
Alright, I have done so.
Now, use this number to form 2 more 3-digit numbers like this. If the number you choose is ABC, then the first number is CAB. That is, with the ones digit shifted to the left end of the number. The other number is BCA. That is, with the hundreds digit shifted to the right end of the number.
I had taken 632. So my first number is 263 and my second number is 326. Yes, I have done it.
Now, add them up.
Okay.
Divide the resulting number by 37.
Alright, hold on.
I claim there will be no remainder.
Yes, you are right.
Let us check whether this trick actually works. Suppose if the number chosen is ABC, the other 2 numbers are CAB and BCA. We know that ABC is equal to 100 times A plus 10 times B plus C. CAB is equal to 100 times C plus 10 times A plus B, and BCA is equal to 100 times B plus 10 times C plus A. So, if we look at the sum ABC plus CAB plus BCA, that is equal to 100A plus 10B plus C plus 100C plus 10A plus B plus 100B plus 10C plus A. Upon simplification, we get this as 111 times A plus B plus C. But we can write 111 as 37 times 3. So, 111 times A plus B plus C can be written as 37 times 3 times A plus B plus C, which is divisible by 37. Students, now let's try to solve some puzzles where letters takes the place of digits in arithmetic sum, in which we need to find which letter represents which digit. So, it is more of like a cracking a code. But before we begin to solve the puzzles, we have few rules to follow. Let's look at them. Rule number 1. Each letter in the puzzle must stand for one digit. Each digit must be represented by one letter. Rule number 2. The first digit of a number can't be 0. Thus, we write the number 56 as 56, not as 056 or 0056. A rule we would like to follow is that the puzzle will have a single answer. So, let's solve the following puzzles. The first puzzle is find A and B in the given addition. It is given that 3A plus 25 gives B2. Students, there are two letters A and B whose value we need to find. If we study the addition in the ones column from A plus 5, we get 2. That is a number whose ones digit is 2. For this to happen, the digit A should be 7. So, the puzzle reduces to 37 plus 25 gives B2. Since the sum of ones is 12, we will carry ones to the tens place, and hence the addition in the tens column gives 1 plus 3 plus 2 is equal to B. That implies B is equal to 6. So, we get A is equal to 7 and B is equal to 6. Now, let's look at another puzzle on multiplication. Find the digits A and B given AB multiplied with 6 gives B. Students, this also have two digits A and B whose value we need to find. Since the ones digit of 6 times B is B, it must be that B is equal to 0 or 2 or 4 or 6 or 8. Since A can't be 0, that is because by our rule 2, B can't be 0. So, if B is equal to 2, we have A2 multiplied with 6 gives rise to 222. Then 6A plus 1 is equal to 22, where such a digit A does not exist. And similarly, for B is equal to 6, the digit A can't exist. So, finally, if B is equal to 8, we have A8 multiplied with 6 giving rise to 888. Then we have 6A plus 4 is equal to 88, which implies A is equal to 14, which is a 2-digit number, and hence it is not possible. Thus, we have only 4, and we observe that for B is equal to 4, we have A4 multiplied with 6 gives 444. Then 6A plus 2 is equal to 44, which implies A is equal to 7. Clearly, A is equal to 7 and B is equal to 4 satisfy, since 74 multiplied with 6 is equal to 444. Therefore, the correct answers are A is equal to 7 and B is equal to 4. Students, here we end up the class. Before we wind up, let's recollect what all things we have learned today. We started our class with the general form of numbers, followed with we played many games with the numbers, and also we could explain the tricks behind each of the game. Later on, we solved few puzzles on numbers in which we found the values of the letters given in the problems. Further, we also solved few puzzles in which we found the values of the letters given in the puzzles by following few rules. So, in the next class, we will be discussing more about the divisibility of the numbers. Hope you have enjoyed the class. Have a good day. Thank you.